Welcome to another lecture of our data structure playlist. Today we are going to learn about queue. So what is the rule of the queue? First see. So unlike stack, in queue insertion and deletion done from different ends. We saw that in stack insertion and deletion are done from the same side, but in queue the insertion and deletion operations are done from two different sides. That's why the rule is known as FIFO, that is first in first out, or we can say last in last out. Okay, just like a queue in real life, the first one in queue will be the first one to leave from the queue. Okay, so now let's see, the insertion operation in queue is known as enqueue, that is done from the rear end, and the deletion operation is known as dequeue and it is done from the front end. What are the other operations? The other operations are like is full, is empty, peak, like this. Okay, so suppose we have a queue of size 5, so it is just like an array 0 1 2 3 4. Okay, we are implementing the queue with an array, so this is now an empty queue. So for an empty queue, the front and rear both values are -1. Okay, so whenever the first element is inserted in a queue, suppose 2 is inserted in the queue, then we do front and rear both we increment by 1. So now front and rear both are 0. Okay, because there is only one element. So and after that, no matter whatever element we insert, the front will be fixed, but the rear is going to be incremented every time. So now after 2 we insert 10 or enqueue 10, then the front is remaining at 0, but the rear is incremented and we insert the 10 at rear position of queue. Okay, so we write queue of rear equals to 10, like that. Now again if we want to insert a value that is 20, then again the rear value will be incremented first, then the 20 will be inserted. So see, front remains at 0 but rear remains at 2 now. So now let's see a dequeue operation. So dequeue will be done from the front end. Okay, that is the first element will be deleted. So this is the wrong part. Okay, so this is the wrong dequeue. It is only applicable for stack. So this is not going to be like this. The dequeue will be like this. Okay, so dequeue will be like this. Now front is here at 10. Okay, this is front and this is rear. So this 2 will be deleted, not the 20. So okay, so remember this is for stack. I wrote this one to make you understand that this is not the case. Okay, so this is the real case. So we do what? We do not do rear minus minus, we just do front plus plus. The problem of queue is the wastage of space, and the application is CPU scheduling, process scheduling, these type of things. Okay, and the two conditions here are also present, overflow and underflow. When this happens, I will be showing you through code. Now let's see the enqueue operation. So first we need to take the element which we need to insert in the queue from the user. So we scan the element from user. After that we check the overflow condition. Okay, that is if there is a space in the queue to insert any element or not. Okay, so what is the condition for the queue to be full? That the rear will be equals to size minus 1. Okay, size minus 1, that is the last index. So if the rear is in the last index, that means the queue is already full and now it will be showing us overflow. So if we want to insert a value in our full queue, then it will be showing us overflow. Okay, that is if the rear is equals to size minus 1. Now for an empty queue, how to insert for an empty queue? So how do you know that the queue is empty? When the front and rear both are -1, so front equals to -1 and rear equals to -1, then when both of them are -1, then we know that the queue is empty. So now we do what? We make front and rear both as 0. We made front and rear both as 0 and we insert the value as rear index of queue. Okay, so that's how we do it. And if there is the queue is not empty and not full, there are some elements in the queue but there is also space for more, then we just increase the rear by 1, that is incremented by 1, rear plus plus, and we insert the value at rear index of the queue. Okay, and now let's see for dequeue operation. So first for dequeue we need to check the underflow condition, that is if the queue is already empty. So when the queue is already empty, when the front and rear both are -1, then the queue is already empty. And now if you want to delete from an empty queue, it will show us underflow. So now if there is only one element left at the dequeue, then we do what? So when there is only one element, then the front and rear are both at the same point. Okay, so when the front is equals to rear, that means only one element present in the queue. So if we delete the only element present in the queue, it will become an empty queue, and we know for an empty queue, front and rear both are -1. So we make front equals to rear equals to -1. If there is more than one element, then we just increment the front by 1, and that means our front element is deleted now. So we just increment the front by 1. Okay, so now if we check the now let's check the display function. So if the queue is empty, then we will print that the queue is empty. That is the condition for an empty queue. And if the queue is not empty, then we start a for loop from I equals to front to I less than equals to rear, and we increment I by 1 every time and print the values. Now let's check the code. First we have global variables, that is our front, rear, and both are initialized with -1 values. And we have size. Also we have an array of named queue, which max size is defined as 100. And we have the function prototypes of enqueue, dequeue, and display. Now in the main function we have an infinite while loop, which will run infinitely until we decide to exit from the loop by user. Also before that, I am asking the user to keep the size of the queue, and it should be less than equals to 100, because that's our max size defined, and we are scanning it. And inside the while loop, we are asking the user to give a choice for the operation he wants to do, that is enqueue, dequeue, display, or he wants to exit it. And inside the switch case, we are doing the program. So now let's see the functions. That is, first we will be seeing the enqueue function. So we are asking the user which value he wants to enter, and now we are checking that if the queue is full or not. So if the queue is full, that is rear equals to size -1, then we are printing that it is overflow condition. And if the queue is empty, that is rear equals to -1 and front equals to -1, then we make front and rear both as 0, and we enter the value at rear position of the queue. And else, that is if the queue is not empty and not full, then we just increment the rear first, and then we enter the value in our rear position of the queue. So now let's see the dequeue function. Dequeue or deletion will be done if the queue is not already empty. So first we will check that if the queue is already empty or not. If it is already empty, then we cannot delete, so it will be underflow. If there is only one element in the queue, then after deleting it, the queue will be empty queue. So we will first print the value which we are deleting, that is the front of queue, and now we will be printing it, and after that we will be deleting it by making the front equals to rear equals to -1, that is the now queue is empty. And else part, that is there is more than one element in the queue, so it will be just printing the value at the front position and increment the front value by 1. So that means the first value is deleted now. Now for the display function, check if the queue is empty or not. If it is empty, show the empty message. If it is not empty, run a for loop from front to rear and print them. So now let's run it and see. So first the user is asked to enter a size, and the size entered by the user is 3. So now I am enqueuing first. So I have selected one, and now I have given in the value 10. So now 10 is entered. Now I am dequeuing. Now 10 is deleted again. So now the queue is again empty, and now if I want to try delete again, it will be showing me underflow. So now let's enter again. So now I am entering 10, 20, and 30. So I have entered 3 times now. So if I want, now the queue is full. So if I want to enter again, so it will be showing me overflow. Okay, so now my queue is already full, see, and now I am trying to enqueue again. Suppose I am enqueuing 40. So see, it is showing me overflow. That is, our conditions are working correctly. So now let's dequeue again. So now 10 is deleted. Okay, because the 10 was the first element, not 30. So 10 is deleted. Now our queue is 20 and 30. So display it and see 10, 20 and 30 is printed. So now let's delete it again. Now 20 and 30 both are deleted. And now if I want to delete again, so it will be showing me underflow, and the queue is empty now. So if I try to display, so it is showing me empty queue. And